In the previous session, we have discussed about the uniform convergence as well as point-wise convergence. So could you recollect the definition of it, or you want me to remind once? You want me to give the concept a little again? Right. Now, the main objective here is whenever you have a sequence of functions fn of x, we are verifying that whether this sequence of functions converges to the function, a unique function or not. So how do we verify that? By simply calculating limit n tends to infinity fn of x. If the limit is existed, the resultant will be framed as a function. We are calling it as f of x, the limit function. And we are checking that this sequence is converging uniformly or pointwise. If it is not uniform, it is pointwise to f of x. So how do we choose that? We calculate fn of x minus f of x. We simplify the expression and we find that if this value is less than epsilon, then what could be the term number m? If you are able to find a unique term number m such that whatever the x you take in the interval, epsilon and m will agree, then it is called uniform convergence. Whenever the term number m agrees with epsilon for some x only, for some other x, if you want to find another term number, we call it as pointwise convergence. So if you want to distinguish between these two in a simple nutshell, suppose you have taken epsilon is equal to 1 by 4, corresponding to 1 by 4, you should be able to find a unique term number m such that always this value is less than epsilon for every x in the interval you have taken. It means if I have taken interval as closed AB, then for every point in closed AB corresponding to 1 by 4, this is the term number. If I have taken epsilon is equal to 1 by 2, for every x in closed AB, this is the term number. I should specify like that. However, if term number agrees with all values of x and it varies from 1 or 2, that means for a single epsilon, I have to find 2 or more term numbers in this interval, then such type of convergence is called pointwise convergence, not uniform convergence. Okay? That was the whole idea. Any more questions, or is that clear? Please ask your queries. Right. Then let us start with the problems. Then it will give you a good idea on what to do. So, suppose we have taken fn of x is equal to nx by 1 plus n square x square. The question is given that show that x equal to 0 is a point of non-uniform convergence. Show that x equal to 0 is a point of non-uniform convergence. Okay, please take a note of it. Now I request you to calculate limit n tends to infinity fn of x. So this is nothing but f of x I am calculating. So give me the value here, what it will be if I apply the limit. Are you able to compute? So can you say what it is if you calculate limit for the given function? Right, 0, because in numerator and denominator you take n square as common and you apply the limit, so you will get 0. So everyone agrees with that, right? Since interval is not yet specified, by default we assume that the function is defined from R to R. The sequence of function fn is defined from R to R. Now what we are going to do, we have to build a relation between epsilon and the term number. So let us assume that epsilon is greater than 0 and you calculate mod fn of x minus f of x. It is just like building a relation between the term number and epsilon. So if you simplify the value, it is nothing but modulus of nx by 1 plus n square x square minus 0, and since we are taking the values as positive, x is somewhat real number, we can take like it as n into modulus of x by 1 plus n square x square. That we are going to take it as. And how to find the relation between epsilon and the term number? So let us assume that this value is less than epsilon. So initially you have taken that epsilon is greater than 0 and we are choosing that epsilon is bigger than this. So using this criteria, you have to build a connection between the term number and epsilon. How to simplify that? So taking that value, we can say this implies n into mod x is less than epsilon plus epsilon into n square x square. So again you are going to write it as epsilon n square x square minus n into mod x plus epsilon is greater than 0. Accepted? Right. Now if you observe that it is a quadratic equation, and can you give me what is the variable there? N. You take it as the variable as n. Right. Now if you feel that it is a quadratic equation always giving the positive values, so you should take that the discriminant b square minus 4ac must be greater than 0. Right. In other words, the value of n always greater than the discriminant. Do you agree for that? The root value n must be always greater than the discriminant. Then only you will get the result as greater than 0 for a quadratic equation. So assuming that, you can say the value of n must be greater than, so here minus b means mod x plus square root of b square minus 4ac you are calculating, so x square minus 4 into epsilon square x square by 2a 2 into epsilon into x square. So you can cancel x by taking x square common inside. So from this you can say that n must be greater than 1 plus root of 1 minus 4 epsilon square by 2 epsilon into mod x. What it is actually, if you want to choose a term number as an integer, so if you fix that as n always indicates the term number, so m must be greater than this value. So this is the expression for m. Please understand. We are finding an expression for the term number. If this is epsilon, what could be the term number expression? That is actually you are finding. So you are able to find a connection between epsilon and term number, hence it is called convergence. Now the thing which is remained with us is whether it is uniform or not, we are verifying. So whether this expression is always valid for whatever the x you take, then it is called uniform convergence. If this expression of a term number m is not valid for certain x, then it is only point-wise convergence. Clear? Now you have taken the entire real number system R. So you can take x as any positive number, you can take x as any negative number. So whatever the x you take, this is the corresponding term number. You are going to take m as bigger than this expression. So if you take x is equal to 5, then what could be the term number? It must be greater than 1 plus square root of 1 minus 4 epsilon square by 2 into 5. If you take x is equal to a negative number, say minus 3, since it is a modulus, always you are going to get a term number. Do you agree? So this expression is valid for positive x as well as negative x. Now if you take x is equal to 0, then is this expression valid? It becomes undefined, because as x tends to 0, this expression will tend to infinity. So for x equal to 0, this expression is not valid. So you are going to find another expression. So we say that x is equal to 0 is point of non-uniform convergence. So what does it mean? In the interval what you are taking, if you exclude 0, then it becomes uniform convergence. If you include 0, it becomes non-uniform convergence. It is just point-wise convergence. Clear? Any questions? If you have any doubts, you can ask. Yeah, I am saying that the word uniform convergence says that you take any epsilon, you should find unique expression for term number so that it is valid. That means the expression is valid for all x. Exactly. Irrespective of the x you are taking in the interval, the term number m is always dependent on epsilon only. Please understand. If epsilon is equal to 1 by 2, term number m is fixed for that 1 by 2 only. Just imagine the thing. That's what I am saying. Here m value is dependent on x also. X is involved. X is that's why. So it is not uniform at x. So in one way you can say that if in the expression of term number, if x is not at all involved, you can say it is called uniform convergence, because you have identified a single expression with regard to epsilon. That's it. That's why I'm saying it is only point-wise convergence. Uniform convergence means M is fixed. In the question it is asked only 0 is, show that 0 is not the point of non-uniform convergence. That's why we fix it to 0 only. That's why we fix it to 0 only. So you are saying that if x is, then for a given epsilon m varies. Agreed? Yes. So it is point-wise convergence. Since the question is posed on only 0, we are fixing the concept of 0 only. It is the basic level problem. Later, while doing the advanced problem, you will get the full idea. Please understand. We are doing with the basic problem now. Fine. This method we will use for the basic level problems. For the advanced, we have the other method, which is Weierstrass test. But on the whole, you understood the concept, right? How to tackle with a problem? Right. Now let us take the other one. Show that Fn, where Fn of x is equal to n square x by 1 plus n square x square is non-uniformly convergent on closed interval 0, 1. Non-uniformly convergent on closed interval 0, 1. Now let us calculate the limit function first. So f of x is equal to limit n tends to infinity fn of x. Now you tell me about the limit function, how it comes. So if you common n square in the numerator and denominator, and what could be the value? On the given interval. So I will say that since the interval is including 0 also there, you are going to write like this. So whenever you take x as a non-zero number, it will be 1 by x. Whenever you take x equal to 0, it will be 0. Agreed? So this is the limit function. All of you agree for that? Any questions? Right. Now let us take that 0 less than x less than or equal to 1. You simply calculate mod fn of x minus f of x. You assume that epsilon is greater than 0, and let us simplify the value. So this will be n square x by 1 plus n square x square minus 1 by x. Since x is positive, there is no need to put a modulus. So please calculate the LCM there. So I say that if you calculate the LCM, you are going to get the value as 1 by x into 1 plus n square epsilon x square. So we say that this could be less than epsilon. Please check with the LCM part. Agreed? All of you. Fine. Now, from this expression, you are going to build a connection between epsilon and the term number m. So you take reciprocal here. So x into 1 plus n square x square is greater than 1 by epsilon, implies 1 plus n square x square is greater than 1 by epsilon into x. So n square x square is greater than 1 by epsilon x minus 1. So n square is greater than 1 by epsilon into x cube minus 1 by x square. So if you take n, it must be greater than root of this value. Agreed? Any questions with regard to the simplification? Say. Accepted, all of you. Right. So you have built a connection between epsilon as well as term number. So as x tends to 0, this expression is going to give the infinity. So it is not possible to choose a positive integer m such that this value is less than epsilon for all n greater than or equal to m. So hence we say that it is a point of non-uniform convergence. Clear? That was the conclusion of the problem. So for basic level problems, the only procedure which we follow is we calculate the limit function. We assume that after simplifying this expression that could be less than epsilon, and we try to build a term number and epsilon relation. That's it. Because you have taken x as positive, right? So that's why I have removed modulus. Because after calculating LCM in the numerator you will get -1, right? Since modulus is there, I treat it as positive. That's why I have taken +1. Yeah. So as x tends to 1, it will be so if you take x is equal to 1 minus 1, 0, right? So n must be greater than 0. It means that from term number 1 onwards, it becomes convergence. You are specifying the term number, right? That's it. So for what x, you are finding a term number. That is the most important thing on the whole. If this is x, so after calculating n value, here what I am saying that for whatever the value of x you consider, you are going to find a term number here. Do you agree or not? Say. So whenever x equal to 0, in that case you are unable to find a term number, because for x is equal to 2 you will have a term number, for x equal to 1 you will have a term number, but for x is equal to 0 you cannot find a term number using this expression. Agreed? So you are unable to find the unique expression, hence it is the point of convergence. It is not uniform convergence. It is a point-wise convergence. But it is asking closed interval 0, 1. That is true. Yes, in the interval 0, 1, you can fix the term number, right? But if you take x is equal to 0, you cannot find a term number. But irrespective of x equal to 0, yes, for x equal to 0, f of x is equal to 0, right? This expression is not valid. You are going to find another term number. you are going to find another term number. Yes, that's what I am saying. This expression is not valid. So this expression is valid only for x is greater than 0. So it is not uniformly convergent at x equal to 0. That is what I am saying. It indicates you have taken 0, 1, right? See, for every x, you should be able to determine the term number. That was the question. Whenever you are unable to determine the term number, you can say it is not uniformly convergent. It is just point-wise convergence. That's it. For every point in the interval, you are checking, not for a particular points. The expression which you are finding, it must be valid for every x, not only for a certain kind of x. Okay? In bifurcation, how 0 for x equal to 0? So here you are asking the part of limit function, right? See, if x equal to 0, what will be fn of 0? So if you apply the limit, it is also nothing but 0, right? That's why I have taken f of x is equal to 0 there. I have taken f of x equal to 0 there. F of x is nothing but the limit of fn of x always. Yes, it is undefined for x equal to 0. That's it. Because you are unable to find a term number there. Clear? Right? Now, let us go with the part that since always calculating the relation between epsilon and n is greater than something, having such kind of expressions, how is fn of x non-uniformly convergent in closed interval 0, 1? See, I am mentioning the conclusion as 0 is the point of non-uniform convergence. That's it. I am framing the conclusion as 0 is the point of non-uniform convergence. That is the way I am writing the solution. I am not talking about the points which are bigger than 0 and less than or equal to 1. Right? That's why, since you are getting a confusion with regard to this kind of approach, the best we are going to use is yes, question is for closed interval 0, 1. See, if at least one point is there to show that at this point the function is not uniform convergent, then it is done, because you are checking for the whole interval. If the condition is violated at least for one point, it is enough. That's it. If I say that it is uniformly convergent, for each and every value of x, I should be able to determine the term number. As and when it fails, it is not uniform convergence. Since it is failed at 0, I am saying that it is not uniformly convergent. That's it. Yeah. Now, coming to Weierstrass M-test, it says that you calculate the limit function f of x, then you calculate fn of x minus f of x, the modulus value, and you assume that this is nothing but y. Now you are going to calculate the supremum among this. It means that by substituting what value of x here, you are getting the biggest value of the function that you are checking. So in other words, if you use the symbol mn for it, you are going to calculate supremum of mn such that for all x in the interval. And it says that if the value of this mn tends to 0, the supremum of mn tends to 0 as n tends to infinity, then by Weierstrass M test, the convergence function which you have taken is uniformly convergent. If this value is not tending to 0, maybe you will get a number or you may get a undefined value, whatever it is. Apart from 0, if you get any other number, it is called only point-wise convergence. That was the definition given by Weierstrass M test. Okay. So please take a note of that. Then let us do some random problems on it. After noting, you please inform. So let us take that fn of x is equal to x by 1 plus nx square for all x belongs to R. And the question is, converges uniformly on any closed interval AB. This was the question tag. The function converges uniformly on any closed interval AB. Okay. So after having the fn of x, let us calculate the limit function f of x. So by simply applying limit n tends to infinity fn of x, can you give me the value, the limit function value, by calculating the limit n tends to infinity fn of x? Is that 0? Right. So straight away, let us take that modulus of fn of x minus f of x. And this value, if you, since the limit function is 0, it is straight away nothing but fn of x. So modulus of x by 1 plus nx square. Now you take the value as y, take y is equal to x by 1 plus nx square. I think you know the procedure, that how to calculate the maximum of a function. First we calculate dy by dx. From it we determine the value of x by making the derivative equal to 0. Whether that x value gives the maximum of the function or not, we calculate the second derivative d square y by dx square. By substituting this x value here, if you say that this is less than 0, then the corresponding x gives the maximum value of the function. That was the approach we usually follow. Am I correct? We calculate two derivatives, first derivative as well as second derivative, right? So if you calculate dy by dx, so you do the formula u by v, straight away I will write the value as dy by dx is equal to 1 minus nx square by 1 plus nx square whole square. Please check on that. Take a minute of time and please do that. Because it is simply doing differentiation u by v model. So if you make the derivative as 0, so if this is identically equal to 0, from this we can say that 1 minus nx square equal to 0. From this we say that x is equal to 1 by root n. Agreed? Right. So if you substitute x is equal to 1 by root n here, therefore y becomes 1 by root n by 1 plus n into 1 by n. So nothing but 1 by 2 root n. Accepted? Now, whether this 1 by 2 root n is maximum value of the function or not, if you want to know, you are going to calculate the second derivative d square y by dx square from this, and if you substitute x is equal to 1 by root n there, it must be less than 0. Right? Now let us do for that. X may be anything, right? You can take x as positive or negative, anything, right? Yes, we should take x is equal to minus 1 by root n also. That is also true. In that case, it will be minus 1 by 2 root n. And since you have calculated only y, then and while checking for Weierstrass M test, we calculate the modulus of y. We are not only taking y, we are taking the modulus of y. So it is nothing but supremum of modulus of fn of x minus f of x you are taking actually. So this is the expression of it. So for calculating the differentiation purpose, I will take this as y. Okay. Now, if we calculate the second derivative, so I will say that you are going to get it as minus 2nx into 1 plus nx square, and then minus 4nx into 1 minus nx square whole divided by 1 plus nx square whole cube. So can you check on that? The second derivative part. And if you substitute x is equal to 1 by root n there, in d square y by dx square, you are going to get the value as minus root n by 2, which is less than sorry, which is less than 0. Please check for that, because you are able to do the calculus part. I feel so. That's why I left for it. So is it required for you to calculate dy by dx and d square y by dx square? Differentiation part. So you do that and confirm me the answer. After taking the feedback from you, then I will move ahead. So I request everyone to give the feedback on it. Is that value correct or wrong? Minus root n by 2 is less than 0 by substituting the value in d square by dx square. Fine. So now the thing is, the maximum value of the function maximum y is nothing but 1 by 2 root n. Now the question is, if we have written formally maximum of modulus of fn of x minus f of x, such that x belongs to the interval whatever you have taken is nothing but 1 by 2 root n. Now this value tends to 0 as n tends to infinity. Accepted? Therefore, by Weierstrass M test, the given function converges to f of x uniformly. That's it. That is the conclusion. So here you are not bothering about the epsilon, term number, x, etc., etc. We are only bothering about the maximum value of the function. If it tends to 0 as n tends to infinity, it is uniformly convergent. Otherwise, it is not uniformly convergent. Okay? So please take a note of it. Either of the thing is applicable. You can do the previous thing as well as Weierstrass M test. Please understand that Weierstrass M test is an advanced one compared to the previous one. See, whenever you have certain methodologies, the methodology is only defined to get authentication or the solution with respect to the problem. For this kind of problems, this is good. For this kind of problems, this is good. On the whole, you are yielding only one result. If you compare the drawbacks or advantages of this method, earlier you simply have done mod fn minus f, assuming that this is less than epsilon, you are able to find a term number. Is it convenient or not? Having an expression for m, does it involve more calculation part? Say, is that involved more calculation part in evaluation of the term number m, an expression for it? No. So if you are able to say that that expression is valid for every x, then it is uniformly convergent, otherwise not. If you are unable to decide that that expression is valid for every point in that interval, then in such cases what happens? Weierstrass M test comes. Now here you need to calculate the first derivative, second derivative, you need to calculate the maximum value of the function, then you have to ensure that it tends to 0 as n tends to infinity. Now things gets complicated, but always this is the most accurate one compared to the previous one, because authentically you can say that since you are not at all bothering about epsilon term number concept, simply you can say that if it is tending to 0, uniformly convergent. If it is tending to another number, it is not uniformly convergent. That's all. You are simply confining like that. Okay? So you can solve a problem either of the procedures. That is up to your choice. If he particularly asked using Weierstrass M test, then you are able to do that. Otherwise, you can use the epsilon technique or M test technique. Both are acceptable. No wrong at all. Why the concept of epsilon technique is there? Let me say, I just want to take one small problem which gives an idea that suppose we have taken fn of x is equal to tan inverse nx for all x greater than or equal to 0. Now, suppose it is given that you are going to show that it is uniformly convergent on any closed interval not containing 0. Let me say it is uniformly convergent on closed AB where A is positive and pointwise convergent. Let me say it is given like that on closed interval 0B. Suppose the question is framed like this. Now let us do as usual. You take f of x, limit n tends to infinity fn of x. Since you are taking for all x greater than or equal to 0, then you may take x as 0 and you may take x as positive. So if you take x as 0, the limit appears to be 0. If you take x as positive, it will be pi by 2. Accepted? Now, let us use the technique of epsilon here. So, if you take x as positive, what could be this value? Can you tell? Can I take it as cot inverse nx? The value? Because I can say is this a valid thing with regard to trigonometry? Since modulus is there, I am going to write it as cot inverse nx. Any questions on this? Right. Now, if you choose that, see, modulus is there always. If you choose that cot inverse nx is less than epsilon, from this, again you are going to simplify that and you are going to get an expression for it, for n. So, as and when you get an expression, it becomes automatically uniformly convergent. That's it. So, apart from calculating the first derivative and second derivative, it is somewhat comfortable for getting a relation between the epsilon technique and Weierstrass test. However, if you are able to solve it by simply using dy by dx, d square by dx square, getting a value for x and get what value gives the bigger thing, you can do like that. That is also acceptable. So, with regard to examination point of view, I suggest you more on Weierstrass test. But for some problems like this, apart from doing all these derivatives, it is somewhat comfortable finding a connection between term number and epsilon. Yes, n value is depending on x value. See, however, I can say that you can fix the term number. The question is asked, it is not uniformly convergent, right? See, let me say, if we have taken like this the real number system, for if we have taken x, from this part onwards it is becoming convergent. Suppose if we have taken x here, from this part onwards it is become convergent. So on, at a particular moment, a unique term number will exist, right? A unique term number will exist, right? That's why it is uniformly convergent. Please understand, for every x you are getting a term number. I will agree with it. Now see, what could be the possibility of selecting the maximum among the term numbers? Let me say, so if you simplify that, can I say that you are going to get the value of n as n must be greater than cot epsilon by x. Am I correct for that? Or here if you take that nx is less than cot epsilon, then 1 by nx is greater than 1 by cot epsilon. So again, 1 by n is greater than x by cot epsilon implies you should be able to find a term number here, right? So on the whole, you can say n must be greater than cot epsilon by x. Can we say like that? Yes, for different values of x should be m. See, I am saying that for every x you are getting a term number m. That I agree with you. Now see, for different values of m you are getting. See, the main thing here is, let me say, for if we have taken x here, I will say m is equal to 10. It means that from 10th term onwards everything is converging. For this x, I will say that m is equal to 15. That means from 15th term onwards everything is converging. From this onwards I will say that m is equal to 12. That means from 12th term onwards everything is converging. So on the whole, if you observe these two, from 15 onwards everything is converging. Accepted? So are you able to find a unique term number m or not? That's why it is uniformly convergent. Now you got the idea? So can I say that is the cot function is decreasing or increasing? Can I say it is a decreasing function, cot function? M value is unique. You are on observing the m values, you are defining a unique m value. Please understand. From that expression, m is varying for different x, I agree. But on observing these m values, can you fix a unique m or not? That is the thing. Okay? Clear now? Right. So if I say that cot function is decreasing, since you have taken a closed interval AB, I will say that cot epsilon by A is the big value, because we have found n in terms of like that. So what happened? Whatever the x you take, if you choose m is bigger than cot epsilon by A, then you have identified a unique term number m such that for every x it is becoming converging. That's it. So it is uniformly convergent. So if you take the closure interval which is having 0, so if you put cot epsilon by 0, then it becomes undefined. So term number does not exist. So it is not uniformly convergent on the closure interval containing 0. Okay? Since you are getting that, since the value of m is depending on x, is it point-wise convergence or uniform convergence? That thing you are thinking in that mind like so. I hope so. Am I correct? So that's why, to avoid that confusion, if x would have been in numerator, then it will not be uniform convergent. So you say that it will become x by cot epsilon. So it is increasing so on. That's why it is not uniformly convergent. You are unable to find a unique term number, right? On observing that, that's it. Because the term number is goes on increasing, it is not stagnating. That's it. So to avoid that confusion, we are using the Weierstrass test by simply going with the part of differentiation. Let me take one more thing. The advantage of Weierstrass test is sometimes it may not be easy to simplify the expression of mod fn of x minus f of x. So in that case, what is the other way to do? So m-test will be most useful. So let us take one more example, then we stop our discussion on this concept. We have winded up this chapter. So let me say you have taken that fn of x is equal to nx into e power minus nx square for all x greater than or equal to 0. The limitation for m-test is only the limit existence, isn't it? That's all. You are calculating the limit, right? If you are unable to determine mod fn of x minus f of x, that's it. See, earlier you have calculated mod fn of x minus f of x. You have obtained a function 1 by 2 root n. You know, limit n tends to infinity. What will be 1 by 2 root n? It is somewhat okay. Now what happens if you simplify this expression? You got a complicated thing here. Applying the limit is somewhat difficult. So if it will be in the form of undefined, then we use L'Hospital rule to evaluate the limit. Even though L'Hospital rule is not at all working, then there is a limitation for M-test. That's all. If you don't know how to calculate the limit, then that is the limitation for M-test. Otherwise, it always holds good. Okay. Now, so this was the problem I have taken. Now let us calculate the limit. So if it is in the form of undefined, we use L'Hospital rule equals to limit n tends to infinity x by accepted the limit part. So if you consider mod fn of x minus f of x, so you take that y is equal to nx into e power minus nx square. Now see, if you assume that this value is less than epsilon, if you want to build a connection between epsilon and term number, how do you evaluate n here? So you got that nx by e power nx square is less than epsilon. From this you can do the necessary simplification. I should be able to determine that n must be greater than something. So can you define that? At least is it possible to define a connection such that n is greater than something using this kind of relation? So in such cases, the concept of epsilon and determined term number will fail. So the concept of M-test comes here. So that is the advantage of M-test. Fine. So let us calculate dy by dx first. So applying UV technique, so I will say that you are going to get the value as n into e power minus nx square into 1 minus 2nx, 2nx square, right? So please check on that. I took the terms as common and I have done like that. So if you make that dy by dx is equal to 0, so you will get that x is equal to 1 by 2 root n, sorry, 1 by root 2n. So please confirm me this value and this value, the calculation of dy by dx and the value of x. So if you want to say that this value gives the maximum of y, so if you substitute x is equal to 1 by root of 2n here, then let us go for it. N into x by n into 1 by root of 2n into e power minus n into 1 by 2n. So these two gets cancelled. root n by root 2 e. Accepted? If I substitute x is equal to 1 by root 2n in y, the maximum value of y will be this, root n by root 2e. And if you want to say that that value is maximum, I need to calculate the second derivative, that is d square y by dx square. So if I calculate d square y by dx square, let me say, if I calculate d square y by dx square, again for this expression using the product formula uv, so I am going to get the value as minus 2n square into x into e power minus nx square and 1 minus 2n square plus 2. That was the part. So if you substitute x is equal to 1 by root of 2n in the second derivative value, you are going to get the value as minus 2n square by root 2n into e power minus 1 by 22. So since this value is negative, it gives the maximum value for us. So check for the second derivative as well as the substitution part in this expression. If you substitute x is equal to 1 by root 2n. So the maximum of y which you have obtained is maximum y is equal to root of n by 2e, nothing but root n by root 2 into root e. Since as n tends to infinity, the above value tends to infinity. So the maximum of y is not tending to 0. Therefore, by Weierstrass test, it is not uniformly convergent. In other way, you can say that by Weierstrass test, it is not uniformly convergent. You can take the limitations of Weierstrass test. If you are able to find an advanced test so that it becomes uniformly convergent, then that could be the limitation of Weierstrass test that you can say. Okay, so please take a note of that. But this is the overall concept of uniform convergence, right? So on the whole, if you want to give weightage with respect to the concept of maximum and minima, you have already learned in calculus. That's why I am not repeating this, because the same thing you are going to do in calculus. So if you have learned maximum and minima in calculus, that is sufficient. I can say one more thing, that in real analysis you have learned the Raymond's definition, and in paper 1 the same question is given. I think it will be limit n tends to infinity summation root of n square minus r square. I think it will be n into something is equal to some pi by 4. I hope so. But this part actually under real analysis. But the problem is taken under Raymond's definition concept, and it was given in paper 1. Similarly, the concept of same maxima and minima, relative extrema, what you have learned in paper 1 will come here. But it is limited to single variable function only, not for multivariable function. Please understand. So we are not taking the maxima minima for the multivariable functions. You are taking the maxima minima for only single variable functions. That's it. That we will do here. That is why it is nothing but a repetition of the previous class. Right. So the common part for paper 1 and paper 2 will be this thing, maxima and minima, and Raman's definition, not complete Raman integral, only Raman's definition. That's it. So at this moment, we want to conclude our discussion on entire real analysis. So from tomorrow onwards, we will take linear algebra. So my intention is to take a introductory bar orientation class with regard to linear algebra. Then I will take one more class on Wednesday. So is this expression suffice for you or require more with regard to uniform convergence? The concept and problem solving tactics. I just want to take 1 minute on this. Earlier, with regard to my opinion, as far as my knowledge, my limited knowledge permissions, I will say that up to 2016, the level of UPSC is mainly concentrated on toughness. How tough you can pose a question on that, and later, hardly for each part, 3 parts will be given for each question ABC. From 2017 onwards, you can check the pattern that the level is moderate and 4 parts are given for each question. The compulsory question you will have 5 parts, for the others you will have 4 parts. Do you agree? So for moderate level preparation, as per the class notes is enough, and if you are halfway down for each topic with regard to the standard textbook, you will have always a good chance of getting mains and you will have a good qualifying rank. So it is on the speed, because as and well the paper goes tough, people may get discouraged over taking math optional. So they have changed their mindset, I hope so. And secondly, toughness is there. Among the 4 questions, I will say that 3 questions are, 1 is easy, 2 are moderate, 1 is tough. That one tough part is taken from research thing. Usually you can take the concept of research gate. You can take anything like uniform continuity, differentiation, Riemann integral, take a word, type under research gate. So as and when you find a research paper, the examples they are taking actually. I will say the question with regard to question paper 1 question with regard to uniform continuity, I have solved half the question and the remaining I have taken from research gate, the other part of it. So they are taking the extractions of this thing. And one good thing is they are concentrating on the examples, not on the exercises. That's why always we have a good chance of winning math. That's it. So because just imagine, I'm a lecturer, I will do my part, but you are a student, if only 3 hours are given, a pen and paper is given to you, you have to get the whole thing in your mind, the whole preparation, and you have to think a new concept at that moment and solve the question, how difficult it is for you. Not only for you, for every student. That's the thing. So they cannot do something strange in the exam paper. That's why you can have the things. Half of the question part will be taken from ResearchGate, which is somewhat feeling different. Apart from everything is nothing but standard textbooks. That's it. That's my opinion with regard to the UPSC pattern.